Ever wondered how sailors crossed vast oceans before technology? Can you imagine setting sail with nothing but the stars and your wits to guide you? Medieval mariners faced terrifying uncertainty every time they left shore, yet somehow managed to find their way across featureless seas to distant lands. Number 10. The legacy of medieval navigation. The techniques medieval sailors developed continue to fascinate us today. These ancient methods formed the foundation of modern navigation and allowed civilizations to connect in ways previously unimaginable. When Christopher Columbus set sail in 1492, he relied on techniques refined over centuries by countless unnamed sailors who braved the waters before him. Their collective knowledge, passed down through generations, enabled the great explorations that fundamentally changed our world. Maritime navigation evolved differently across various seafaring cultures. Mediterranean sailors developed techniques distinct from those in Northern Europe, while Arab navigators pioneered mathematical approaches that would eventually revolutionize how everyone sailed. Chinese explorers like Zheng He commanded massive treasure fleets that navigated with sophisticated compass techniques and detailed sea charts generations before similar tools became common in Europe. The Portuguese deserve special recognition for systematically advancing navigation during the Age of Discovery. Under Prince Henry the Navigator's patronage, Portuguese mariners ventured ever further along Africa's coast, each voyage pushing the boundaries of known waters. Their navigational breakthroughs, especially developing methods for determining latitude, transformed what was possible at sea. These adventurers didn't just discover new lands, they discovered new ways to find those lands reliably. Medieval navigation's legacy extends beyond technical achievements. It represents humanity's enduring desire to explore, connect, and understand our world. The sailors who first developed these methods faced the unknown with remarkable courage. They sailed into uncharted waters with rudimentary tools and often paid with their lives when those tools or their skills proved inadequate. Yet their persistence gradually transformed terrifying, mysterious oceans into known, navigable highways connecting distant civilizations. Number 9. The rise of portolan charts. Have you ever tried finding your way using only landmarks? Medieval sailors faced this challenge daily. Before the age of scientific cartography, sailors relied on portolan charts, practical sailing guides that revolutionized maritime navigation. These charts first appeared in the late 13th century, primarily in Mediterranean maritime communities. Portolan charts differed dramatically from earlier medieval maps. While monastery-produced maps often prioritized religious symbolism over geographical accuracy, portolans focused entirely on practical navigation needs. They depicted coastlines with remarkable precision and featured an intricate network of rhumb lines, straight lines showing compass directions between ports. These lines created a web-like pattern across the chart that allowed navigators to plot courses using compass bearings. The creation of these charts involved careful compilation of information from experienced sailors. Chart makers interviewed captains and pilots, collecting thousands of observations about coastlines, harbors, and hazards. This practical knowledge got translated into visual form through painstaking draftsmanship. The resulting charts contained incredibly accurate coastal details despite being created centuries before formal surveying methods. Portolan charts featured several distinctive characteristics. They typically oriented north at the top, a convention we now take for granted but which wasn't universal in medieval cartography. They focused on coastlines while leaving interiors largely blank or decorated with illustrations. Most importantly, they included detailed information about safe harbors, dangerous reefs, and landmarks visible from sea, practical information a sailor needed for survival. The accuracy of these charts sometimes appears almost impossible for their era. The Mediterranean coastline on 14th century portolans matches modern outlines with surprising fidelity. This precision stemmed not from scientific surveying but from generations of accumulated observations by sailors who literally risked their lives on the accuracy of their knowledge. Each successful voyage refined the collective understanding of maritime space, gradually producing charts of remarkable reliability. Number 8. Dead reckoning and the challenge of distance. How far have you traveled when you can't see land? This question haunted medieval mariners. Dead reckoning became their primary method for estimating position when landmarks disappeared below the horizon. This technique required sailors to track their ship's direction, speed, and time traveled to calculate their location. Direction came from the compass, but determining speed presented greater challenges. Medieval sailors used primitive but effective methods like tossing a floating object overboard and timing how long it took to pass from bow to stern. Some ships used knotted ropes with regularly spaced markers, the origin of the term knots for maritime speed. A sailor would toss a wood float attached to this line overboard and count how many knots passed through their hands during a specific time measured with a sand glass. These measurements contained significant error margins by modern standards. Currents, winds, and human error in timing all affected accuracy. However, experienced navigators developed an intuitive feel for adjusting their calculations based on conditions. They understood that strong following seas meant their speed estimates needed adjustment, or that certain wind conditions would push them off course in predictable ways. The most skilled navigators maintained mental models of their voyages, continuously updating their position estimates based on all available information. They might adjust calculations after observing seawater color changes indicating underwater features, spotting particular seabirds known to stay within certain distances of land, or noticing changes in wave patterns suggesting nearby islands. These subtle environmental cues informed their dead reckoning calculations. Dead reckoning errors compounded over time, making long voyages increasingly uncertain. After several weeks at sea without astronomical observations or landmarks, a ship's actual position might differ significantly from its calculated position. This uncertainty explains why finding small islands in the vast Pacific remained nearly impossible until more accurate navigation methods developed. It also explains why sailors celebrated sighting expected landmarks, confirmation they hadn't become hopelessly lost at sea. Number 7. Celestial navigation, reading the stars. Did you know medieval sailors essentially used the stars as their GPS? Celestial navigation represented the most sophisticated aspect of medieval seafaring. While dead reckoning helped track progress along a known route, astronomical observations allowed sailors to determine their absolute position, particularly their latitude. The North Star, Polaris, provided the simplest method for determining latitude in the Northern Hemisphere. This star appears almost directly above the North Pole, making its angle above the horizon approximately equal to the observer's latitude. A sailor in London, latitude 51°N, would see Polaris about 51 degrees above the horizon, while a sailor in Lisbon, latitude 38°N, would see it 38 degrees up. This relationship gave navigators a reliable way to determine their north-south position. Measuring this angle required specialized instruments. The earliest was the camel, adopted by European sailors from Arab navigators. This simple device consisted of a rectangular wooden card attached to a string with knots at specific intervals. The navigator would hold one knot between their teeth while aligning the card's bottom edge with the horizon and top edge with Polaris. Each knot corresponded to a specific latitude, allowing surprisingly accurate position determination. More sophisticated instruments gradually appeared. The quadrant, a quarter circle marked with degree measurements, allowed more precise angle readings. Later, the astrolabe, originally an astronomical calculation device, was adapted for maritime use. By the late medieval period, cross staffs and back staffs provided increasingly accurate methods for measuring celestial angles. Southern Hemisphere navigation presented greater challenges since Polaris isn't visible there. Instead, sailors learned to use other celestial features like the Southern Cross constellation or the height of the sun at noon. The noon sun's altitude varies with both latitude and season, requiring more complex calculations but ultimately providing similar positioning capabilities. The practical knowledge required for celestial navigation spread through maritime communities via oral tradition and apprenticeship rather than formal education. Experienced navigators taught younger sailors to recognize key stars, use measurement instruments, and make necessary calculations. This knowledge transfer system meant navigation techniques remained largely confined to professional mariners, creating a specialized body of practical astronomy distinct from the theoretical astronomy practiced in medieval universities. Number 6. The revolutionary magnetic compass. Have you ever been lost in fog so thick you couldn't see your hand? Medieval sailors faced this terrifying reality regularly. The magnetic compass transformed maritime navigation by providing direction when environmental cues disappeared. This revolutionary technology allowed voyaging regardless of visibility conditions. The compass reached European sailors around the 12th century, likely arriving via Arab traders who had adopted it from Chinese inventors. Early maritime compasses consisted simply of magnetized needles floating in water bowls. These primitive instruments evolved into dry pivot designs with needles mounted on pins underneath protective covers, eventually incorporating wind roses marking directional points. Compass use wasn't straightforward by modern standards. Medieval compasses indicated magnetic north, not true north, and navigators gradually recognized this discrepancy, what we now call magnetic declination. The angle between magnetic and true north varies across the globe and changes over time. Experienced navigators developed regional rules of thumb for compensation, knowing, for instance, that in certain waters they needed to adjust course slightly eastward or westward from their compass heading. Fascinating superstitions surrounded early compass use. Some sailors believed garlic or onions could disrupt compass function, while others performed special rituals when first introducing a compass aboard ship. These beliefs reflected both the mysterious nature of magnetism and the compass's critical importance to survival at sea. As one Portuguese saying went, "Without a compass, only angels navigate." The compass fundamentally changed sailing patterns by enabling reliable navigation in poor visibility. Before compasses, sailors primarily practiced coastal navigation, staying within sight of shore whenever possible and beaching their ships at night. With compasses, they could maintain course through fog, darkness, or stormy conditions. This technological advancement made open ocean voyaging significantly safer and more reliable, expanding the possible range and season for maritime travel. Maritime cultures incorporated the compass differently. Mediterranean sailors quickly adopted standard compass roses divided into 32 points, while Northern European traditions maintained simpler divisions for longer periods. By the late medieval period, standardization gradually emerged as maritime communities exchanged knowledge through commercial interactions, creating common navigational language and techniques across European seafaring cultures. Number 5. The importance of sea soundings. Ever thought about how sailors avoided running aground? Medieval mariners constantly worried about unseen underwater hazards. Taking soundings measuring water depth became a crucial navigation practice that sometimes meant the difference between safe passage and disaster. The technique seems remarkably simple. Sailors dropped weighted lines overboard and measured how much line paid out before hitting bottom. The physical process involved specialized equipment including lead weights called sounding leads, shaped to collect seabed samples. These weights typically had hollow bottoms filled with tallow animal fat that picked up sand, mud, or shell fragments from the sea floor. Experienced navigators could identify their position by examining these samples, recognizing distinctive seabed characteristics of specific areas. Sounding lines themselves evolved into sophisticated tools marked with standardized indicators. Different colored cloth strips, leather pieces, or knots at specific intervals allowed sailors to quickly read depths even in poor visibility or at night. The standard measurements on English sounding lines were marked in fathoms, approximately 6 feet, creating a specialized depth vocabulary that persists in some nautical contexts today. Taking accurate soundings required considerable skill. The sailor, called the leadsman, would stand in the ship's chains, platforms extending from the side, and swing the lead forward while the ship moved. This technique allowed the weight to hit bottom directly below when the ship reached that point, accounting for forward movement during measurement. In shallow or dangerous waters, ships might station multiple leadsmen calling out depths in sequence, creating constant depth awareness. Soundings provided more than simple depth information. They helped navigators determine position when other methods failed. Sailors in familiar waters compiled mental maps of depth patterns approaching harbors or navigating channels. Experienced pilots could navigate fog-bound channels almost exclusively by soundings, following known depth contours with remarkable precision. This knowledge was so valuable that some ports kept their exact sounding patterns secret, protecting local pilots' employment from outsiders. The most sophisticated use of soundings came in combination with early charts that included depth notations. Portuguese and Dutch navigators pioneered these charts, marking safe channels through complex coastal waters. By the late medieval period, some European maritime regions had developed detailed bathymetric knowledge, with charts indicating underwater features with surprising accuracy given their technological limitations. Number 4. Weather prediction and wind patterns. Could you navigate using only wind and clouds? Medieval sailors had no weather satellites or forecasts, yet successfully predicted storms and seasonal patterns. Understanding weather became a survival skill developed through generations of observation and experience. Sailors developed extensive vocabularies describing wind and cloud patterns. They recognized specific cloud formations that preceded storms and distinguishing between local weather phenomena and major approaching systems. Mediterranean sailors identified distinctive regional winds like the Mistral and Bora, each with characteristic behaviors. Northern European mariners similarly cataloged wind patterns in the North Sea and Atlantic, creating a practical meteorology based entirely on observation. This weather knowledge influenced navigation planning at every level. Captains scheduled voyages around known seasonal patterns, avoiding hurricane seasons in the Caribbean or monsoon periods in the Indian Ocean. Daily decisions incorporated short-term weather predictions, with experienced navigators constantly scanning the horizon for warning signs requiring course adjustments or shelter seeking. Sailing ships depended entirely on wind power, making wind pattern knowledge doubly important. Navigators needed to understand not just dangerous weather, but also how to use prevailing winds to their advantage. They developed routes utilizing predictable wind systems like the Atlantic trade winds, creating standard sailing passages that persisted into the steam age. Portuguese sailors discovering the Volta do Mar, return from the sea technique revolutionized Atlantic travel by deliberately sailing away from their destination to catch favorable winds, a counterintuitive approach that dramatically improved voyage times. Local pilots developed sophisticated understanding of how winds interacted with coastal features. They knew precisely how mountain ranges might funnel winds to create dangerous accelerations or protective wind shadows. This microclimate knowledge represented valuable intellectual property, often kept secret among pilot guilds or passed down within families, creating specialized local knowledge communities crucial for safe navigation. Medieval sailors couldn't measure atmospheric pressure, yet recognized many signs we now know relate to pressure changes. They observed animal behavior, water conditions, and subtle atmospheric qualities like distant sound transmission or unusual refraction effects. These observations allowed surprisingly accurate short-term forecasting without instruments. The red sky rhymes familiar today: red sky at night, sailors delight; red sky in morning, sailors take warning, originated in this period, reflecting observable correlations between sunset-sunrise colors and approaching weather systems. Number 3. The Human Navigation Network. Would you trust your life to a stranger's directions? Medieval sailors regularly did exactly that. Beyond technical methods and instruments, human knowledge networks formed perhaps the most important navigation system in the pre-modern maritime world. Pilots, local navigation specialists with detailed knowledge of specific harbors or coastlines, played crucial roles in commercial shipping. Major ports maintained pilot organizations whose members guided arriving vessels through tricky local waters. These pilots possessed detailed mental maps of underwater hazards, current patterns, and local landmarks invisible to visiting sailors. Their services weren't optional. Many ports legally required arriving ships to employ local pilots, both protecting shipping and ensuring income for the pilot community. Knowledge exchange between sailors created informal but effective information networks. When ships encountered each other at sea or in port, captains typically exchanged navigation information, reporting hazards, weather conditions, or pirate sightings. These interactions created a constantly updating maritime intelligence system. Harbor taverns functioned as information exchanges where sailors shared experiences and warnings, creating collective knowledge bases in major ports. Navigation knowledge passed between generations through apprenticeship systems. Young sailors learned from experienced navigators through direct observation and instruction during voyages. This practical education system transmitted both technical skills and subjective knowledge difficult to capture in writing, like how to read watercolors indicating depth changes or recognize the distinctive smell of land after weeks at sea. Different maritime cultures maintained specialized knowledge suited to their environments. Arab traders in the Indian Ocean mastered seasonal monsoon patterns, while Norse sailors developed sophisticated techniques for navigating fog-prone northern waters. When these traditions encountered each other through trade or colonization, they sometimes exchanged techniques, creating maritime knowledge hybridization. Portuguese exploration success partially stemmed from their willingness to adopt navigation methods from Arab, African, and eventually Asian maritime traditions. The most sophisticated manifestation of human navigation networks appeared in the Pacific, where Polynesian navigators developed remarkable methods for island finding. These navigators memorized star paths, wave patterns, and animal behavior specific to particular islands. They could detect distant islands below the horizon by observing reflected wave patterns or cloud formations. This knowledge passed through rigorous training traditions, creating specialist navigators who guided canoes across thousands of open ocean miles without instruments. Number 2, maritime superstition and religion. Would you pray before checking your GPS? Medieval sailors lived in a world where religious practice and navigation intertwined inseparably. Maritime culture blended practical techniques with spiritual practices, creating navigation systems addressing both physical and metaphysical concerns. Ships routinely carried religious items believed to provide protection. Mediterranean vessels might include shrines to patron saints of sailors like Saint Nicholas or Saint Elmo. Northern European ships carried Christian symbols alongside older protective traditions. These religious elements weren't merely psychological comfort. Sailors genuinely believed divine protection influenced navigation success and safety. Prayer became integrated into navigation routines. Crews performed specific prayers when departing harbor, taking celestial sightings, or facing storms. Portuguese explorers carried priests aboard who conducted religious ceremonies at significant navigation milestones. Columbus maintained detailed records of religious observations alongside his navigation logs, seeing divine guidance as integral to his voyage success. Sailing schedules incorporated religious calendars. Medieval shipping often planned departures around saints' days considered favorable for voyaging. Some maritime communities avoided sailing on specific religious holidays or during periods associated with dangerous supernatural activity. These calendar-based decisions merged practical seasonal awareness with religious observance, creating integrated planning systems. Navigation-related miracle stories circulated widely in maritime communities. Accounts of saints appearing during storms or guiding lost ships to safety reinforced beliefs in supernatural navigation assistance. These narratives weren't seen as contradicting practical navigation methods, but complementing them, providing additional protection when human skills reached their limits. Not all supernatural beliefs were formally religious. Sailors maintained complex superstition systems regarding navigation. Some believed whistling could summon winds, but might attract storms if done improperly. Others performed specific rituals when crossing significant navigation boundaries like the equator. These practices created psychological frameworks for understanding the uncertain maritime environment, helping sailors manage the constant anxiety of ocean voyaging in an age before reliable weather prediction or position fixing. The relationship between religion and navigation eventually evolved as scientific methods developed. However, throughout the medieval period, most sailors saw no contradiction between practicing careful celestial navigation while simultaneously seeking divine guidance. The heavens provided both practical direction through star positions and spiritual protection through divine forces believed to reside there. This integrated worldview characterized medieval navigation's distinctive approach to maritime challenges. Number 1. Beyond technology, the navigator's mindset. What separates someone who gets lost in their neighborhood from someone who can find a tiny island in the vast Pacific? Medieval navigation ultimately transcended tools and techniques, emerging from distinctive cognitive approaches developed through experience on the water. The navigator's mindset represented a specialized way of understanding space, time, and environment. Expert navigators developed extraordinary environmental awareness. They noticed subtle cues invisible to ordinary observers, slight water color changes indicating underwater features, distant cloud patterns suggesting land beyond the horizon, or distinctive smells carried on winds from unseen shores. This heightened awareness came from both natural aptitude and years of intentional observation, creating almost supernatural-seeming abilities to read environmental information. Successful navigators maintained continuous situational awareness. Unlike modern sailors who might check position occasionally, medieval navigators maintained constant mental models of their location, continuously updating these models with new information. This cognitive process required remarkable concentration sustained over weeks or months at sea. The best navigators developed specialized memory techniques for maintaining these mental maps despite sleep deprivation, stress, and the disorienting effects of ocean voyaging. Problem-solving flexibility distinguished great navigators from merely competent ones. When instruments failed, whether obscured celestial observations or unexpected currents disrupted dead reckoning calculations, successful navigators improvised solutions using whatever information remained available. This adaptability proved crucial in an era before redundant navigation systems or rescue services. Lost medieval ships stayed lost, creating extreme selection pressure for navigators who could solve problems independently. Medieval navigation required remarkable mental calculation abilities. Navigators performed complex mathematical operations without formal mathematical training, developing practical computational methods suited to shipboard conditions. They created specialized techniques for calculating position based on limited information, often using physical tools like knotted ropes or marked boards as calculation aids rather than performing abstract mathematics. Perhaps most importantly, successful medieval navigators balanced confidence with humility. They needed sufficient confidence to make life-determining decisions with limited information, while maintaining enough humility to recognize their limitations and adjust plans when conditions changed. This psychological balance separated long-lived navigators from the overconfident who eventually disappeared at sea, or the overly cautious who never ventured beyond familiar waters. The navigation mindset passed between generations through both formal knowledge transfer and subtle cultural transmission. Young sailors absorbed not just technical skills, but ways of thinking about maritime space and environmental interpretation. This cognitive apprenticeship created distinctive maritime thought communities with specialized perceptual abilities and decision-making approaches optimized for navigation challenges. Did these ancient seafarers possess skills we've lost despite our technological advantages? Could you find your way home if all your devices failed tomorrow?